And first, we'll move on to the static system. Here, the output of the static system at any specific point of time depends on the input at that particular point of time. So, output of any system, any static system, right, at any specific point of time. For example, n is equal to 5, right? So, I am going to calculate the output y of 5, which depends on the input at that particular point of time. Then y of 5 will be depending on x of 5 only, not on all other timings. Only on that particular point my output depends on the input signal. So for doing such kind of operations, no memory is required, right? So no energy storage elements are required in this case. So here the input output relationship, if you are describing our relationship between the input and output variables, it does not involve the integrals in the case of continuous time system or derivatives in the case of discrete time system. So if I am representing my signal for the static system, so y of n is equal to 8 into x of n. You can have any kind of signal here, and 8 into, this is one example, that's all. You can have any number over here or without any number, right? So y of n is equal to 8 into x of n. So the n value should be common here. So at that particular point of time, my output depends on the input. So this is the static system. And coming to the dynamic system, output of the, sorry, here it should be dynamic. Output of the dynamic system at specific time depends on the input at that particular point of time and also at all other times. It is possible, right? So in that condition, y of n is equal to, suppose for example, x of n is, consider always remember x of n is your present input signal, x of n is your input signal generally, and y of n is your output signal generally, and x of n is the present input signal, and x of n minus k is the past input signal, and x of n plus k is the future input signal. And similarly, coming to the output side, the same rule applies. Y of n minus k is the past output, and y of n plus k is the future output. So here the dynamic system depends on the input at that particular point of time. So if I want to calculate my output y of n, then it depends on the signal at that particular point, that is x of n, and also on other times. It is also possible. The combination is possible here. So I can have my example as y of n is equal to, simply I can have 8 into x of n, or y of n is equal to 8 into x of n plus 4 into x of n minus 3, past input signal. Or along with this combination, I can have one more future signal also. So x of n plus 1. So these are all the multipliers or weights given to the signals here. So if you are having present, or if you are having either past or future input signal in your equation, output equation, the present input may or may not present, but if you are having any kind of past input signal or future input signal, then that system will coming under the dynamic category. And here in this case, if you are dealing with such kind, then we are in need of memory to store the past values, isn't it? So memory or energy storage elements are required for the dynamic system. So here it will involve the integrals or derivatives if I am representing the input and output relationship. So this is the dynamic system. So by looking at the equation itself, we can able to say whether it belongs to a static system or dynamic system. If any kind of past signal or any kind of future signal or the combinations present in our equation, right, difference equation, then naturally that will come under the dynamic system category.